So the question often comes up when we see a question like this one. It's getting a little bit more complicated for factor theorem. Is there a quick way, is there a shortcut to determining what the factors are I should be considering? So this is sort of how we determine our factors. Again, plus or minus all the possible factors of the last digit here, the 10, divided by the factors of the 6. And so these are our possibilities. Obviously quite a number of them. What is that? 14 and another 12, so 26 different possibilities. So what we want to do is try to figure out, is there a nice easy shortcut? I guess my first suggestion is, kind of looking at the individual question for sure. I see a 6 here, a 5, a negative 21, and a 10, and the answer kind of jumps out at me that these add up to 11, plus this ends up being the same as this number. So just kind of looking for patterns in the numbers is sort of a first key. I can say for sure the number 1 plugs into all of these. I get 6, 5, plus 10 is 21, minus the 21 here will be the 0. So although the question looks scary, one of the first things I always try just by default is -1 or +1. And looking at this one, I can see right off the bat that one of those two is going to work, the positive in this case. So looking for patterns in the numbers is a good idea for sure. Recognizing as well that because these terms are both positive, if I start plugging in large numbers like the 10s, the 5s, this is going to get extremely large positively. This is going to get extremely large positively. And this is already 10. So although this is going to be a negative number, it's going to be much smaller than these values when I start cubing the number 10, cubing the number 5, and so on. So the positive, big positive values right off the bat, I can kind of eliminate as possibilities as well. Okay. So now let's assume I didn't see the 1 right off the bat, and I'm just going to try numbers. So maybe as a starting point, I'm going to try the 2, because it's a nice number to work with. And so here's my equation: 6 times 2x cubed plus 5 times 2x squared minus 2. So you can't see it very well. Actually, up here, though, it shows it written out nicely. When I hit equals, I see the value's 36. What that tells me then is that, and I haven't maybe done this enough, but although p at 2 is not 0, is really what I'm interested in, the fact that p at 2 is actually 36 tells me that 2 is too big. Okay, and that kind of follows from what I said before, that based on these numbers, the fact that they're both positive especially, bigger numbers are going to be a problem here. So p at 2 is too big. Again, allows me to kind of mentally eliminate the positive values here, if I hadn't seen that already. So if p at 2 is too big, I can choose a number that's smaller. So we'll try p at -1. So there's p at -1, and I find that it's an answer of 30. So again, p at -1 ends up being too big. Now, the reason this happens, of course, is because I skipped over the 1. So the 1 was the important one to see here. But p at -1 is 30. So again, it's still too big. So choosing a number that's smaller, we can try the -2. So negative in here, negative in here, negative in here. -2 is 24. It gives me 24. Still too big. What if we try the next one on the list, which was 5/2? So -2.5. And what we see is we get to the number 0. Okay, so by thinking about just kind of the numbers that I had, I was able to eliminate some of these bigger numbers right off the bat. By trying a number, the number 2, and realizing that it was too big, I was able to kind of eliminate again the larger positive values. I avoided the kind of the really messy fractions initially, just because, although certainly I could have tried this one. But as I saw that 2 was too big, -1 was too big, I was able to sort of keep going in that direction now, from -1 being too big, -2 being again slightly too big, or a little bit less too big but less or so. I was able to kind of keep heading in the right direction and get to here. Now, of course, that all is predicated on the fact that I ignored the obvious P1. This being too big should have led me to try the P1, and I would have got there with that one as well. So just a couple of options as far as finding that first factor goes. Once I found one, of course, I used the factor theorem to solve. But again, P1 was probably the best one to find from the very beginning.